Hello and welcome to our small documentary about our trip to Oxford University's Museum of Natural History. Upon arrival, as you can see, it's very lovely. It's a Gothic architecture which was really impressive and quite intimidating aesthetic at first, but once we got to meet the person who was greeting us, it became very intimate and very nice to look at. So we were super excited to get in there and learn about some of the taxons that we chose to do for our project that ended up being beetles, but we didn't know at the time. But I'll go into a bit more about why we chose beetles, Coleoptera above. To understand why we were inclined to focus on the specific taxon, I'm going to first talk about the evolutionary path that has sculpted how incredibly diverse this taxon has come to be. But firstly, let's define how to classify Coleoptera. Normally, as an adult, the order is classified by the presence of elytra, which I will explain a little bit more about later. Folding membranous wings, so very leathery, very tough, under these elytra. Antenna specifically, normally segmented in about 9 to 11 different segments, although obviously there is a fluctuation in that number because there is so much diversity in this taxon. It's very difficult to generalize it so. As larvae, the classification sort of hinges on visible segments on the torso. Normally that's about 3 to 5. Normally it's 5, but sometimes there is only 3 visible segmentations on the body. However, there's quite a giveaway characteristic, and that being a hard capsulated head segment. And obviously 3 pairs of legs on the torso. That's typically how they classify beetles. As we can see here, we can see an example of the elytra. And those membranous wings, as you can see in the top right there. It's very fascinating to look at, and I will go into a bit of information about how they came to be in evolutionary terms. Another wonderful example of the true diversity of this taxon, you can see an example of the true radiation of this taxon and the differentiation and the specialization of different adaptations among this taxon, which is truly why I think we were inclined to focus on beetles, just because there is so much diversity and so much specialization within this taxon. So, a bit about the evolutionary journey of Coleoptera. It was established at the end of the Mesozoic era, about 145 million years ago. It did have a sort of prototype. It was aptly named Proto-Coleoptera, which is thankfully quite easy to remember. It was mostly found in fossilized amber, which I will talk a little bit about later on, or it was cast, so to speak, in sedimentary rock, meaning that the actual remains of the animals weren't fossilized very well, but they left an impression on the rock. Which is how we were able to identify early examples of Coleoptera. The earliest example was dated back about 280 million years ago in Eastern Europe. The Coleoptera's precursor often had very distinctive ribbing, which is sort of the sculpting of the thorax there. Normally this had irregularity within it, and the outer sculpting was very distinctive and very sort of primitive. In the Jurassic period, the modern Coleoptera that we are familiar with today replaced that prototype. These were normally found in amber, encapsulated. The fact that the earliest beetles were found encapsulated in amber in sort of the Jurassic period of trees implied that the beetles were already making a home and feeding within the bark of the trees. The amber is a sap secretion of the tree. As this solidified, it created a amber colour that we are familiar with today and solidified, and therefore encapsulated the beetle that was wandering about in the sap at the time. Moving on from the taxon's impressive evolutionary cycle, I'd like to get into some specific and intriguing species of beetle, and hopefully some of the facts about the different species' diet, morphology, and size will highlight the true level of diversity in Coleoptera. Firstly, we have the Goliath beetle, one of the very largest and most impressive, in my opinion, part of the Scarabidia. They are often found in forest places or equatorial savannas. This specific beetle has a very conditional criteria for breeding. It must have a constant climate, meaning humidity also. The larva may experience shock, physical mutation, and sometimes death if these conditions aren't met. Their habitat is mostly peated substrate, moist and mineral rich for egg laying. Adults require a very specific high-protein diet consisting of tree sap, ripe fruits, and animal dung. Its predators include Hymenoptera, which is quite interesting because this manifests as a parasitic relationship, as the Hymenoptera larvae feed on the body of the beetle. Some mammals also predate on this species, although for most bird species they do seem distasteful. The Goliath beetle is very adaptive and has also succumbed to environmental pressures to adapt. The elytra, despite providing much needed protection of the beetle, held it back during flight. However, dietary motivation and environmental pressure guided the beetle to the adaptation to fold the forewings up and over the elytra to increase the efficiency of flight. Furthermore, hybrids such as G. atlas marry together characteristics such as iridescent blue elytra with a yellow dorsal. This provides a combination of colour which is a warning to predators. Additionally, this also aids with attracting mates. So as we can see, there is great diversity within the species, even in the entire taxon, and Goliaths to me are one of the most interesting and impressive species of Coleoptera. In contrast to the large, dynamic Goliath beetle, I'd also like to mention the bacon beetle, also known as the larder beetle, formerly known as the Domestus lardarius. Its family is in the Bostricoidea, and in comparison to the Goliath, the adults only measure between 6 and 9 millimeters, so vastly different. Their colouring ranges from dark brown to black, with spotted coloration above the elytra. This species has a much simpler requirement for egg laying, and it only requires a damp substrate. Due to this, it allows them to extremely rapidly reproduce, as opposed to the Goliath, which is very slow. For their food, they tend to feed on dried plant and organic material, and tend to live in temperate climates. They also have fewer predators as opposed to the Goliath. So, all in all, they're vastly different size, different coloration, different diet, and different predation within the same taxon. So hopefully this, along with the information about the Goliath beetle, can truly shine light on why me and my group chose to go for this taxon. Hopefully I'm conveying how truly diverse and interesting this taxon is. I hope you've enjoyed, and thank you very much for watching.